Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
So we did the support vector machine regression models in our previous video tutorial 1 to 2, following on our series of video tutorials that focus on predicting our NDVI value for our region of interest based on elevation, rain, temperature, using different regression methodologies or different regression classes, if you want to call it. So we looked at normal time series multiple regression, and its variations thereof, robust and quantile and so forth. We did spatial regression, we did weighted regression, geographically weighted regression, then we did support vector. So remember, we did the random forest model in Earth Engine, and then we exported the derived predicted image of our random forest model to QGIS. But we can also do random forest in RStudio. So this will be the focus of this particular video tutorial, is on random forest regression within RStudio. Okay, so and then we're going to compare it with the random forest model that we did in Earth Engine and see whether they are generally fairly similar or they're very different, whatever the case might be. Understanding that there will be differences. I don't think it will be exactly the same, simply because it's two different platforms and etc. etc. So I assume there's going to be some changes, but I don't think it's going to be significantly sizable changes between the outcomes, the predicted NDVI values. Anyway, so there's some documentation on the web relating to random forest modeling in RStudio, and there's a package that we need to download. There's the random forest library package. There is the package that we have to install, random forest. Okay, so use that package, RStudio R package, to install and to upload, and that's what we're gonna basically use. Let me just go there. So again, first, again, the first part is to generate our template, our raster template, or our blank or empty raster image, where we're going to rasterize our predicted values. So that should be now straightforward with all of them. Okay, so we generate our empty raster or our template. Then the random forest, we're going to generate our training. We're going to generate our training sample and our testing sample. Exactly the same as we did in Earth Engine. So if we go into Earth Engine, you'll see that, let's just quickly go to Earth Engine. You'll see also we split it. Where do we split it now? There we go. We split it, there we go, into our training sample and our testing, also 70-30 rule. So we did do exactly the same in RStudio, 70-30 rule. Okay, so there it is, our 70-30 rule. So we generate that. There we go. Now we can just display the training data and the testing data. So let's go into our training data. You can see our training data. There's 3,286 data points, and there's 8 variables, which is index, NDVI, rain, random, temperature, X and Y. So there's 8 variables within our training set. We do our testing set. We're on that. And you see there's 1973. So let's have a look and see in RStudio what those numbers look like. RStudio. Earth Engine. Training is 3664. Let's have a look and see in our training. 3 to training. Training. There's our training now. There's our training. 3286, and in our an Earth Engine 3664, and our test is 3694. Let's have a look and see in our test. In our test, it's 1973. So there's our first differences, our first initial differences. It's just the numbers there. It's quite different. Okay, but anyway, we're still doing the same as we did in Earth Engine by taking our data set and split it into a 70-30 ratio between training and testing. Now, within RStudio, what we now need to do is to generate this value here, the MTRY. That's the value that we have to this. This MTRY is a variable, you'll see it there, within the model itself, and we have to estimate that number. Okay, so what that is the number of variables randomly sampled as candidates at each split. This can be set to the value found during the tuning process or adjusted based on specific needs. So to estimate that value, that MTRY value, this is the code that we use. Okay, this is the code that we use it. So if we run that code, okay, you'll see the MTRY, the optimal value is 2. There it is. So it's just basically confirming that the best value is 2. Okay, so there it is. So when we do our random forest modeling itself, our regression, we change that to MTR2. We make that the 2 value there. So how do you determine the 2? Basically, you run this code. We understand the random tree. That's just a number that we chosen, selected 100, and I've kept it. If we go into our model within our Earth Engine, we will see that that is also 100. So I've kept the random forest, the number of random forests the same between Earth Engine and RStudio. So we keep that the same. I use my train data. So it's the same as in Earth Engines. You see, I've also used my train data. The features is in my train data. That 71. So up to that, which is still exactly the same. The only difference between the two so far, well, except that the number of trainings and testing data is different, is this variable MTRY that we first have to generate. And well, as I said, we generate it, but you can manually change it. If you want to do 4, you can do 4, whatever the case. So that's to some degree discretionary. The number of forests are totally discretionary. Play around with it, change the numbers, and then evaluate every time the predicted values based on the change of the number of random forest trees to determine roughly the optimum level. Okay, so let's run the equation. Let's run the equation. There's the equation, and then generate the importance of the variables itself. 6 point. So temperature the most important, elevation the second most important, and rain the third most important. If we go to Earth Engine, let's have a look and see. It's different numbers, but you'll see temperature is the most important, elevation second, and rain third. Let's have a look here. The temperature the most important, elevation, and rain third. So the importance is exactly the same order as in Earth Engine. So we're going to generate our prediction, our predicted values based on our training, and we can compare the actual values with the training, which we've done. Let's just go and run that as well. There's the actual and the predicted values. We can generate a mean square error. Mean square error 0.0, that's small, and we're going to plot it. So this is now the training, the actual and the training. not the testing. So all that we've done here is generate the predicted values based on the training set and not the testing set. You see there, it's the training set, train. Okay, so there it is. It doesn't look, first sight it doesn't look too bad. Let's zoom out. It's actual predicted. There's some outliers here. It's not a perfect fit, but it doesn't seem to be bad. We're going to then plot the, do that on the testing, create the predictions on the testing site. So let's run that as well. Same stuff, and the R square. 0 again, very, very small. Let's have a look and see in the previous one if we can find it. Where did we do that now? I can see, where did we do that? There we go. 0.0002 0009. We're going to plot it. It looks pretty much the same. We're going to create the predicted values, and then we're going to plot the predicted values or rasterize the predicted image. There it sits. So there's our predicted rasterized NDVI values based on our random forest model with 100 trees and MTR y being equal to 2, and it is our model that we generate our predicted values based on our model, and then we rasterize it same as what we did previously. We add those values into our empty raster template, we plot it, and then we write it and we generate it, a TIFF file for it, and we save that into our project folder. So I'm not going to play around with this, but we should ideally now change the 100, change these two parameters, play around with these two parameters until we get to something that, well, let me call it, we get to something that we think is the best fit, best model. It generates the best predicted NDVI values. But we're not going to do that now. But yeah, that is supposed to be now our standard practice. So, as I said, we've now created this predicted raster NDVI image from our random forest model, and we put it into QGIS, and here it sits. I've already added it into my QGIS and colored it and all. You see NDVI prediction random forest. Let's just confirm NDVI prediction random forest. So I've imported it within QGIS, and it's so this is the image, the predicted image, rasterized image that we generated in Earth Engine. This one here. Let me just go to Earth Engine. This one here. This NDVI. This one here. Okay, the color schemes are different. Okay, so this image here, the NDVI prediction. Okay, my spelling terrible, huh? Anyway, that is the predicted NDVI image in Earth Engine, and this is how it looks. Sorry, this is how it looks in So we brought that image into QGIS, and then we generated this NDVI predicted image from RStudio. So that's the RStudio version, and that's the Google Earth Engine version. RStudio version, Earth Engine version. You can visually see there's differences. I mean, let's quickly just have a look and see. If we just select those two, you'll see that it's 0.46 and 0.44. So there is a significant difference between the two images. It could be because of that. Could be because of the difference in the sample sizes between the training and the testing. So that could be a reason. It could be because the MTRY value that's different between the two. It could just be because of the extent that's different, because in Earth Engine we work with the actual NDVI raster. Here we generate an empty raster, NDVI raster. and then we populated the data. So there's a couple of points where that could account for the differences. So that's why I'm saying I don't think we'll get it that it's exactly the same, but I don't expect the differences to be that sizable that it's totally different. But nonetheless, you can clearly see there's differences. So we can generate our random forest model within Earth Engine, or we can generate our random forest in RStudio, and we can then open it and compare that in QGIS. Okay, so that is the random forest. We can, as I said, change these numbers around. Let's just for example say we make this. Let's make it 20. Let's for intersect make it 20. Okay, so let's run. Now I'm going to just run it again. You can see the numbers is again different. Let's quickly. I just want to run these. Now let's run it again, but I'm going to make it a T. Oh no, make it 20. Make it a 20 number. Let's see if it works. And let's just quickly have a look and see. Okay, so that's the predicted value now. So let's bring in that. So that's with 100 trees. Random forest trees. Let's add the layer, add raster layer, add the one with 20 trees, open it, add, and let's quickly have a look and see whether there is significant differences. Quantile, classify, apply. So that's 20 trees, that's 100 trees. 20 trees, 100 trees, 20 trees, 100 trees. So let's quickly just select the three of them, add them, and let's see what the numbers look like. So that's the random forest. Let's make it bigger so we can have a look and see. That's the 100 trees. That's the Google Earth one, and this one I would then let's make it still bigger. It doesn't. Okay, so let's quickly make it. This is the 23's 0.42. So that means that between the 200 ones, QGIS. Now, what's the actual value? Sorry, I should have included the actual value to give a sense. You see which ones are. So if we open all the values, so where's my actual value? 475. Then the 447, that's the 100 trees within RStudio. RF, that's 0.446. You can see it's very similar between the two. But this was Earth Engine. And then the 20, you can see is 0.46. It's actually performing better with 20 random forests and not the 100 random forests. So there's definitely room to play around with the number of trees. So let's quickly do that. And then last one that I want to quickly just see if we keep it 20. Let's make it 100 again. Where is it now? Let's make the trees 100 again. And then make the MTR whatever 3. That's 43. And let's run it quickly. And then let's make that 4. Okay, so let's quickly do this. Oops, sorry. Let's quickly run it again and generate it. Okay, there it is. Let's open it quickly in QGIS. Layer, add layer, raster. That's now with 100 trees, but 4. Is it a 4? Or did we do 3? Why did I say 4? Let's just quickly have a look and see. It's 3. I don't know why I decided on 4. But anyway, let's open it, add. Okay, so bring that into where we are with our random forest. So let's properties, give it a color scheme, single band. We're going to quantile, classify, apply. And there we go. So let's select them all. And where we're going to, okay, yes, look at this. See, it will obviously will depend from location to location. So this is very anecdotal. Oopsie. So wow. Come on. Let me just quickly, sorry. I don't know why it doesn't wanna. So have a look there. That value there. Why is it saying derived? Sorry, I must open it up. There we go. Let's open it up. Okay, so where's our actual value? Our actual value is 0.48. So our Earth Engine image 0.44. Our equal RStudio image 0.44. It's very similar, the two. Then we look at our 20 trees 0.44, and then we looked at our MTRY with 100 trees and 3. It's 0.44. Compare that to 0.440. So there is definitely a difference, and it seems like it's difficult to say which one is better or which one. It does certainly looks a bit better with the 4 and the 20. Anyway, that's manual labor, if for lack of a better word, that we have to play around with. That was just, sorry, open the processing toolbox. So that is random forest. That's working with random forest within RStudio, and the idea is to replicate what we've done in Earth Engine. And as I said, to a large degree, it does seem that the two values are very similar, although different, which is expected, but they're very similar. And as I said, what we can do is we can then play around with these two parameters. Let's go back to our optimum level, which is 2. We've got 20 decision trees or random forest trees, which seems to be not optimal. The 20 seems, or the lower number seems more relevant or more better in terms of the prediction than more trees. But anyway, that's just anecdotal. That's something that we have to play around with. But yeah, so that we can do random forest in RStudio, and this is the basic standard script to get going with random forest in RStudio. We can generate a coefficient and all of these sort of things we can try to do as well. And I said, we've rasterized our prediction images and we've exported it into QGIS, and within QGIS we can then add them to our growing list of predictions, rasterized NDVI rasterized predicted images. What's the order? Rasterized NDVI predicted image, NDVI rasterized predicted images, NDVI predicted rasterized images. Most probably that one is a better option to say. So where we're standing now? We're 1, 2, 3, 4. This is random forest. There's 4 random forests. Multiple regression, standard multiple regression, robust multiple regression, LMS multiple regression, LTS multiple regression, RS multiple regression, MM multiple regression, LAD is, my memory serves me correct, it is quantile regression. So those are all these ones, 1, 2, 3, 4, 5, 6, 7. So these 7s are standard time series multiple regressions. Then we have the 1, 2, 3, 4, 5, 6, 7. We have the 7 spatial regression models. Then we have the 1, 2, 3, the 3 geographically weighted regression models. And we have the 2 support vector models regression equations. And I think, if I am correct, this is it for now in terms of our models. our classes of predictions. Okay, so let's stop there. Our next video is where we're going to start looking at these ones in terms of their ranking, in terms of who's better, who's worse, where do they fit, what's the top 5 or bottom 6, whatever the case might be. Because now we've got a lot to choose from. There's really quite a range of methodologies at play here, and we're going to try to evaluate and assess them and compare them to get a rank order for our region of interest for NDVI. So with that said, let's pause for now. Let's pause for now with random forest modeling within RStudio. A nice tool to have in your toolkit, something that I think is it's yielding interesting results. Okay, so let's park there. Let's pause there for now. We'll continue on this particular journey within our border journey. Thanks for joining me. Please remember to like, subscribe, share. Press that subscribe button. It does do wonders. It does help. So please smash that button. For those that have, thank you so much. I really appreciate it. Stay tuned. I'll see you on the other side.